Hey guys, today we're going to talk about exponents and the properties that really can that deal with exponents. So we've talked about when you multiply like bases, you add the exponents. Well, when you divide like bases, likewise you subtract exponents. So if you have a situation where you have b raised to the n over b raised to the n because b and b are the same base, then your answer is going to be b to the n minus n. Okay, and then what if you have a fraction that's raised to an exponent? Well, you give that exponent to both the numerator and the denominator as so. So let's take a look at this, right? For number one, you have 7 to the 10th over 7 to the 7th. Okay, well, if we follow our principle here, our property here, and that's going to be equal to 7 to the 10 minus 7, which is 7 cubed. Okay, right? So likewise, we have y to the ninth over y cubed, right? So that's going to be y to the sixth. We're literally just subtracting here. Okay, another thing is that anything raised to the zero power is 1. So right here, this is going to be 1. Okay. Now the catch is when the difference between 3 and 4 is 0 is on 12 on number 3, but on 4, 0 is on x. So this goes away to 1, right? But I'm left with a negative 9 times 1, so my answer is negative 9. Okay? Hopefully that makes sense. Right? It's very similar to how if you have negative 8 squared, but the negative 8 is not in parentheses, and so the 2 is just on the 8, like this, that is different than negative 8 squared. This one's going to give you a negative 64, and this is going to give you a positive 64. Right? It's a subtle difference. But if the zero is on the number, like it is here, if zero is on the number like it is here, then the whole thing goes to 1. If if this was a whole parentheses, then the whole thing would be 1. But the 0 is only on the x, so the whole thing goes to 1, and I'm left with negative 9. Okay. Now, so number 5, this time the whole thing is equal to the whole thing is raised to the 0 power. So the whole thing is 1. Okay, well ago we talked about how this property says if I have an fraction raised to an exponent, I give it to both. So this is going to be x squared over 6 squared. So I can't do anything about the x squared. So the x squared is just going to be x squared, and then that's going to be 36 because 6 times 6 is 36. Okay, now 7 is a little bit more complicated. It's still doable, right? So I'm going to, here's how we write this. All right, I'm going to say 5 squared times x to the 6 times 2. Because remember, when you raise a power to a power, you multiply. And this is 6 squared. Okay, so that's going to be 25 x to the 12th over 36. Okay, and just like before, when you multiply fractions, if you can reduce at the end, you can reduce before you multiply. Same thing here. If I can reduce before I apply the exponent, great. That means I can reduce at the end as well. But if I can't reduce here, then I can't reduce in the end. So this is not going to reduce. I can move on. Okay, 8. We have again we have negative 2 cubed times a squared times 3 over b 3 times 3. So 2 cubed is 8. Because it's negative, that's going to be negative 8. And that's going to be a to the 6th and b to the ninth. Okay. Number 9. All right. Here, I'm not raising any exponents, but I can reduce this. All right. You do your numbers first. What is 49 divided by 7? Well, that's 7. And then x over 18, or x to the 18th over x squared. Well, that's the same thing we did when we started like number 1 and 2. Okay. So subtract 18 minus 2, that's 16. So this is going to be 7x to the 16th. All right. Same thing on number 10. Negative 10 divided by 20, that's going to be negative 1 over 2. All right. Uh, and then y, 9 minus 4 is 5. So I could do one of two things. I could write it like this, where the negative 1/2 is to this is separate from the y to the 5th, because y to the 5th is technically in the numerator, or you could write it negative y to the 5th uh, squared. Both of these are the same. Both of these work. Right? You'll see them written differently in different answers, uh, but they're both the same. Just so you know. Okay, now this one might be obvious to you, because let's look at this. I have x to the 23 over x to the 23. Well, that's just going to go away because 23 minus 23 is 0. Same thing here. And so my answer here is simply 7 over 3. Okay, here, you have x to the fourth, 4x to the fourth, you have 10x cubed. Those are not like terms. So you could do this a couple different ways. Um, so you could take a GCF out, although we haven't really talked about GCF yet. If you know what you're talking about, if you know what you're doing, you could take that GCF out of the top. But another way to do this is simply separate your fraction, which is totally legal. And so you can say 4x to the fourth over 2x minus 10x cubed over 2x. And then just reduce. When you do that, this is going to be 1 and 2. That x is going away. That's going to be 3. Uh, this x is going away. That's going to be 2. That's 1. That's 5. I'm kind of bleeding all over this thing. But here, this is going to be, the first term is going to be 2x cubed minus 5x squared. So hopefully you can see that you can do this. Uh, and so I said GCF a while ago. And so this is what I mean. So what do the 4 and 10 have in common? They have a 2. They both have at least 3 x's. Like they can x cubed out, and that would be um, x to the, let's say 2x minus 5. And then I can cancel. The 2's go away. That's going to be x squared. And then technically you put the x squared back out. And technically I took out too much. So if I had just left that alone and left this as x cubed and x squared, you see where I'm coming from at this point. Everything can go away. You take out just enough to get rid of the denominator. Everything else stays the same. That's the idea. Hopefully that was helpful and not confusing. If it is, just let me know when we get back to class. All right. So 13. We have a lot going on here. You want to reduce first. So let's do this. What is 55 divided by 11? Well, it's 5. So we have 5. Then we have x squared over x. So that's going to be x here. Y fifth, y cubed. So that's going to be y squared minus, right? 18 over 2 is 9. X to the eighth over x to the seventh is just x. And then y to the ninth, y to the seventh is y squared. Now I have like terms. And so 5 minus 9 is negative 4. X, y squared. Okay. So it looks complicated, but if you take it one step at a time, you'll find that it's actually not that bad. All right. And then our last problem here is just like one that we're familiar with at this point. Um, it says divide the sum of y plus 11 all squared and y plus 11, y minus 11 by 2 pi. Okay. So let's do this. We have uh, y plus 11 squared plus the product of y plus 11, y minus 11. Okay. All divided by 2y. Okay. So we know from a previous lesson that we can multiply this out. This is y plus 11, y plus 11 plus y plus 11 minus 11. Okay, so over 2y. Okay, now let's do this a little bit of time. So we have y squared. So all that's going to be plus 11y plus 11y plus 121. Okay, that's the first part here. That's the first product. Plus we have y squared um, minus 11y plus 11y minus 121. Okay, all this is over 2y. Right? And you'll notice that I have a negative 121 and a positive 121. I have a negative 11y and a positive 11y. Right? Everything else looks the same. That's going to be 2y squared plus 22y all over 2y. And now this looks very similar to what we did on number 12. Again, you can do this straight up, or you could separate it. So let's take a 2y out of the top. If we do that, we're left with y plus 11 all over 2y. These go away. And my final answer is y plus 11. Okay, so once again, this complicated thing turns out to be something simple in the end, and that is quite satisfying. So, hope this helps. I look forward to seeing you in class to talk about it.